How do you inspect an excavator before spending lakhs of rupees on it? In this video, I'm going to take you through the exact checks I would perform before buying one. We'll look at the engine, the hydraulic system, the tracks, the swing bearing, the boom and arm, the final drives, and the electronic control system, and I'll show you how to turn what you find into an actual repair cost, so you can decide whether the machine is a bargain or a money pit. First, record the machine details: model number, serial number, engine model and serial number, manufacturing year, hour meter reading. Check the identification plate on the machine and compare it with the documents. Then ask the owner. How many owners has the machine had? Where was it operating? Was it used for earthwork, road construction, quarrying or mining? Was a hydraulic breaker used? Was it rented to different operators? Has the engine ever been replaced? Has the hydraulic pump been replaced? Has the undercarriage been replaced? Has the boom or arm been repaired? The application is important. A 6,000-hour machine used for normal excavation is not necessarily equivalent to a 6,000-hour machine that spent most of its life working with a breaker in a quarry. So don't evaluate hours without understanding the duty cycle. Now let's talk about operating hours. Suppose the seller tells you the excavator has only 4,500 hours. Don't reject that number, but don't accept it blindly either. Cross-check it. Look at the service records. Look at oil change records. Look at filter replacement records. Check electronic operating hours, if the machine provides them, and then compare all of this with the physical wear on the machine. Look at the pedals, the operator seat, the joysticks, the bucket pins and bushes, and especially the undercarriage. If the hour meter says 4,500 hours, but the machine has extremely heavy wear everywhere, you need to understand why. The objective is not to prove that the hour meter is wrong. The objective is to make sure the complete history is consistent. Now we come to one of the most important tests, the cold start test. Ask the seller not to start the excavator before you arrive. The engine should be cold. Start the machine yourself, if possible. Observe how quickly it starts. Listen to the starter. Listen to the engine. Watch the exhaust, and watch the engine idle. Look for excessive smoke. Look for abnormal vibration. Listen for knocking or unusual mechanical noise. Also check the oil pressure and coolant temperature on the machine display, where available. A cold engine can reveal problems that may not be obvious after the machine has already been warmed up. Now open the engine compartment. Start with the obvious things. Look for oil leaks, coolant leaks, fuel leaks, and hydraulic oil contamination around the engine compartment. Inspect the engine hoses. Check the belts. Check the turbocharger. Check the air intake system. Check the radiator, and inspect the engine mounts. Don't just look for oil dripping onto the ground. Look around gasket joints, hose connections, seals, and the engine block. A small amount of sweating is different from an active leak. The condition and location of the leak matter. Next, check the engine oil. Look at the oil level. Look at the condition of the oil. Check for excessive sludge. Look for signs of coolant contamination. Look for fuel dilution. And if possible, check for metallic particles. For an expensive excavator, I would strongly consider sending an engine oil sample to a laboratory. Oil analysis can provide information about internal wear. Elements such as iron, copper and aluminium can indicate abnormal wear depending on the engine design and operating history. This is much more useful than simply looking at the color of the oil. Now check engine blow-by. Bring the engine to normal operating temperature. Then check crankcase pressure according to the engine manufacturer's procedure. Excessive crankcase pressure can indicate internal engine wear. Possible causes include worn piston rings, cylinder liners, pistons, or cylinder bores. Don't make the diagnosis simply by looking at smoke coming from the crankcase breather. If you're seriously considering buying the machine, measure it. Now the engine needs to be tested under load. Warm the excavator to its normal operating temperature. Then operate the hydraulic functions. Raise the boom, move the arm, curl the bucket, and perform combined movements. Watch the engine while you're doing this. Does the engine maintain its RPM? Does it respond smoothly? Does it produce excessive smoke? Does the RPM fluctuate? Does the engine bog excessively? And does the coolant temperature remain stable? An excavator engine should be evaluated under realistic hydraulic load, not just while idling in the parking area. Now inspect the cooling system. This is especially important for machines operating in India's hot and dusty conditions. Inspect the radiator, the hydraulic oil cooler, the intercooler, the air conditioning condenser, the fan, and the fan shroud. Look between the cooling cores. Dust and debris can accumulate between them and restrict airflow. A machine can operate perfectly at idle and still overheat during continuous excavation. So run the machine under load. Don't make your decision based on a 5-minute idle test. Next, inspect the engine air intake system. Start with the air filter. Then inspect the filter housing, the intake hoses, the clamps, and the connection to the turbocharger. Look for dust around joints and seals. If you find evidence that dust has passed the air filter, investigate further. Fine abrasive particles entering the engine can accelerate wear of the cylinders, piston rings, and turbocharger. Now we come to probably the most important system on the excavator. The hydraulic system. This includes the main hydraulic pumps, the pilot pump, the main control valve, the cylinders, the hydraulic tank, the filters, the hoses, the swing motor, and the travel motors. Start with leakage. Inspect every accessible hose and connection. Look for wet areas, look for damaged hoses, look for cracked outer covers, and check the connections carefully. A hydraulic hose doesn't need to be leaking badly to require replacement. Age, abrasion, and damage are also important. Now inspect the hydraulic cylinders. Look at the boom cylinders, the arm cylinder, and the bucket cylinder. Inspect the chrome rods. Look for scratches, pitting, corrosion, dents, and bending. Then inspect the gland area. Look for oil leakage around the seals. A damaged chrome rod can eventually damage the cylinder seals and gland. So don't treat cylinder rod damage as a cosmetic issue. Next, check the hydraulic oil. Look for contamination, water, metallic particles, foaming, and abnormal smell. If the machine is a serious purchase candidate, take a hydraulic oil sample. Oil analysis can identify contamination and wear trends that may not be visible during a normal inspection. If the analysis shows significant metallic contamination, investigate the hydraulic pump, motors, and control valve before purchasing the machine. Now we come to the main hydraulic pump. This is one component where you should avoid relying on the seller's statement. Don't ask only, "Is the pump good?" Measure it. Depending on the excavator and the manufacturer's test procedure, check the relevant hydraulic pressures and pump flow. This may include pilot pressure, standby pressure, main relief pressure, and pump flow under load. The measured values should be compared with the specifications for that exact machine. Don't use a generic pressure value from another excavator. Different models and configurations can have different hydraulic specifications. Now operate the hydraulic functions. First, test them individually. Then test them together. Raise the boom, move the arm, curl the bucket, swing the upper structure. Then combine the functions. For example, operate the boom and arm together. Then boom, arm, bucket, and swing. Watch the response. Look for slow movement, uneven speed, hydraulic noise, engine bogging, pressure fluctuations, or excessive heating. You're trying to understand whether the hydraulic system is delivering the expected power and response. Next, check for hydraulic drift. Position the attachment safely according to the manufacturer's procedure. Then observe whether the attachment moves without a commanded input. Excessive drift can have several causes. It could be internal leakage in a cylinder. It could be leakage through the control valve. It could involve a load-holding valve. Or it could be another hydraulic circuit problem. So don't immediately blame the cylinder. The circuit needs to be isolated if you want a proper diagnosis. Run the excavator continuously under load. Monitor the hydraulic oil temperature. If the temperature rises abnormally, investigate the reason. Possible causes include poor pump efficiency, internal hydraulic leakage, relief valve operation, a blocked hydraulic cooler, incorrect or degraded hydraulic oil, or excessive leakage through the control valve. Remember, excessive hydraulic heat means that hydraulic energy is being converted into unwanted heat somewhere in the system. Now move to the undercarriage. For a crawler excavator, this is one of the biggest potential repair costs. Inspect the track chains, track shoes, bushings, track rollers, carrier rollers, front idlers, sprockets, and track adjusters. Don't just look at the track shoe. The complete undercarriage needs to be assessed. For a proper inspection, measure the components. Depending on the manufacturer, this can include track link height, bushing dimensions, track pitch, roller diameter, idler dimensions, and sprocket wear. Compare the measurements with the manufacturer's wear limits. This gives you an actual remaining life estimate. It is much better than saying, the tracks look about 70%. A measured wear value is much more useful when negotiating the price. Now test the final drives. Operate both tracks independently. Test forward, reverse, left turn, right turn, and controlled turning. Compare the left and right sides. Look for one track being noticeably weaker. Listen for abnormal noise, check for oil leakage, and monitor temperature after operating the machine. A weak or noisy final drive should be investigated before buying. Next, inspect the swing system. This includes the swing motor, swing gearbox, swing brake, pinion, and swing bearing. Rotate the upper structure in both directions. Listen carefully. You are looking for knocking, grinding, abnormal vibration, or unusual gear noise. Also inspect the swing gear and pinion for abnormal tooth wear. The swing bearing deserves special attention. It supports the entire upper structure and transfers digging loads into the undercarriage. Check for excessive radial or axial play according to the manufacturer's inspection procedure. Also inspect the mounting bolts and swing gear. If the swing bearing has excessive play, don't treat it as a minor defect. Get a proper repair estimate before negotiating the machine price. Now inspect the structure. Look at the boom, the arm, the boom foot, cylinder mounting areas, pivot points, and welded joints. Look for cracks, grinding marks, repaired welds, reinforcement plates, and deformation. Pay particular attention to areas where high hydraulic forces are transferred into the structure. Fresh paint is not automatically a problem, but fresh paint covering an unknown structural repair is something you need to investigate. Look for different paint shades, grinding marks, new welds, additional plates, heat marks, or unusual weld geometry. If you find a suspicious structural repair, use an appropriate non-destructive testing method. Depending on the material and suspected defect, this could include dye penetrant testing, magnetic particle inspection, or ultrasonic testing. Now check the articulation points. Boom to arm, arm to bucket, bucket linkage, boom foot, and cylinder mounting points. Look for excessive clearance. Some play is normal, but excessive clearance increases impact loading and accelerates wear. For a machine with significant pin and bush wear, calculate the replacement cost before deciding on the purchase. Now inspect the bucket. Check the teeth, adapters, cutting edge, side cutters, wear plates, heel, bucket shell, and welds. A worn bucket doesn't necessarily mean you should reject the machine, but you need to know how much it will cost to bring the bucket back to a productive condition. Ask one direct question. Has this excavator ever worked with a hydraulic breaker? If the answer is yes, inspect the machine more carefully. Pay particular attention to the boom, the arm, pins and bushes, hydraulic piping, main pump, control valve, and structural welds. The wear pattern of a breaker machine can be very different from a machine used only for conventional excavation. Modern excavators are electro-hydraulic systems. So now inspect the electrical and electronic side. Check the battery, alternator, starter, wiring harness, connectors, fuses, relays, sensors, display, and electronic control units. Check all warning lamps, work lights, reverse alarm, cameras, and other electrical functions. If an OEM diagnostic tool is available, scan the machine. Check current fault codes, and where the system allows it, check historical fault information. Don't simply clear a fault code and assume the problem is fixed. Now inspect the operator cabin. Check the seat, joysticks, pedals, switches, glass, doors, locks, wipers, mirrors, camera, air conditioning, and emergency controls. Also inspect the condition of applicable protective structures such as ROPS or FOPS. The controls should respond smoothly. Excessive joystick deadband or abnormal control response needs investigation. Now the machine needs to work as a complete system. Start with the cold start. Warm the machine to normal operating temperature. Then travel, swing, operate the boom, arm, bucket, and combined functions. After that, perform actual excavation or another representative load test. Continue operating the machine long enough to bring out temperature-related or hydraulic problems. Then shut the machine down. Restart it while hot. A machine that performs well for 5 minutes may behave very differently after 30 minutes of continuous operation. One useful engineering test is cycle time. Measure the time required for representative movements. For example, boom raise, arm movement, bucket curl, swing, and a complete excavation cycle. Compare the results with the manufacturer's specification, using the correct test conditions. Or compare the machine with another known good excavator of the same model and configuration. This changes the inspection from subjective judgment to measured performance. Now make a repair cost sheet. Suppose the excavator is being offered for 25 lakh rupees. Your inspection identifies 3.5 lakh rupees for the undercarriage, 60,000 for pins and bushes, 30,000 for hydraulic hoses, 40,000 for engine service, 20,000 for electrical repairs, and 30,000 for bucket repairs. That's approximately 5,30,000 rupees of immediate work. So the effective acquisition cost isn't 25 lakh. It's approximately 30,30,000. Now compare that number with another machine. This is how you should compare used excavators. Not simply by asking, which one has the lower asking price?